Hello all, I'm Raghavendran from Team Neutrino Labs and we are here to present our project SwarmLM, the Decentralized Inference Network. So, we're all aware of ChatGPT, and when it comes down to LLMs, running LLMs ain't cheap. So, we all know the fact, and LLMs obviously come with a significant operating expense. And especially if you look at a model like GPT-3, it took almost $1.4 million and TPU V4 chips from Google Cloud Platform. So this sort of models require highly resource intensive platform, and because the transformer architecture is compute intensive. If a company like ChatGPT who's trying to do 175 billion parameter like model is facing outage and then sudden spikes in demands, then there is literally no space for research or civilian use cases. So what we are actually trying to do is we are trying to solve two problems. One is there needs to the infrastructure cannot be a limitation for research efforts when it comes to LLMs, and the open source and the closed source platforms that are already out there like ChatGPT or other models do not make the cut because they are closed source for obvious reasons. So we are coming up with a simple solution that where you decentralize the inference for LLMs. When it comes to large language models, you we are planning to decentralize the inference in terms of layers. So Swarm basically brings down the decentralization approach to LLM's computation architecture. So basically what we have is that the transformer layers would be distributed throughout the network, and there will be an orchestrator who will take care of the orchestration process. And the computation will pass on and the inference will be managed entirely by the orchestrator. The orchestrator will be capable of creating chains of pipeline, which are parallel servers or compute nodes, which will be doing the distributed inference themselves. This eliminates the need for a high power computing mission to run the LLM. So Swarm also incentivizes the contributors that dedicate the resource and helps them to earn tokens through proof of compute. So in the platform, we have two stakeholders. One being the compute node providers who are going to provide the GPU for the computation, and they will be incentivized by proof of compute. And when it comes to LLM users, we are Swarm basically focuses on people who are trying to use this for research purposes. And how it basically works is that they would be pledging some tokens to our bond manager contract. And once they pledge the tokens, they get an API key. Then they can use the decentralized inference network to test and then play around. So we'll quickly run through a demo of the application and then we'll slide back to this. So we have over here the initial screen of our app. So let me just put it up here. So this is the landing page of our application. This is the customer focused part where the customer can basically come in and they can create a API key for themselves. They can just click on add an API key. They can give a name to it, and then they can set a bunch of credits which they are willing to pledge to the market, and then they can just take up the approval part. And once they're done with it, basically the model gets added, and then they can start moving around with the infrastructure. That is, they can start putting the request to the LLMs. So we have over here a simple chat interface um, where they can prompt the LLMs to give a response. So this is basically the site that happens. So this entire decentralization part happens in the background. So it happens in two steps. That is, we have the decentralized compute nodes, which are shown here over in the monitor part. So basically, this is a live health monitor of our distributed nodes, of our compute nodes, which are already hosted in the server. We can have a look at them over here. And if somebody wants to become a part of our network, that is, if they want to become a node provider, we have got the code which anybody can just pull up and then they can run it and then they'll become a part of our node provider. And the moment they become a part of our node provider, their IDs will also get accumulated into our platform. So let's get into the specifics of how this is implemented. So coming back to the implementation architecture, you can put it up simply as this block diagram. So basically, you have the client who's the LLM user who wants to use the LLM for training or for distributed computing. And then there comes the orchestrator whose job is to basically realize the token payouts, handle the orchestration part, and do the API provisioning. Then we have the inference nodes, who are our actual GPU providers, our compute providers. The compute providers would basically be managed through a DHT, distributed hash table. The orchestrator queries the distributed hash table and then keeps updating the hash table depending upon the number of live nodes that are connected in the system. So the detailed functional block diagram goes like this. So the users basically authenticate with panoramas and then they start giving input prompts or output prompts to the LLMs. So the moment the prompt comes in, we have a load balance set of orchestrators which will be taking care of the uh, inference and then governing the token distribution for the compute nodes that are dedicated towards the system. We have two token contracts. One is for SwarmLM token, and the other one is for the bond manager contract. The bond manager contract basically takes care of the pledging part, and it basically allocates the required amount of funds to the compute nodes. So we have deployed the contracts in Arbitrum as well as in Scroll, and we basically use Waco for internal communication in terms of our distributed compute nodes to our DHT. The LLMs are basically stored and retrieved from the IPFS, and then they are used across the nodes that are currently live in the network. Thank you all. This is uh, SwarmLM from Neutrino Labs.